Well, hi, and thanks for joining me here in my shop on it's the Ides of March. It's Friday, March 15th. Getting a bit of a late start in here today, but I'm looking forward to having a lot of fun with this radio. Now, just to review quickly. So I've replaced all the questionable capacitors that are in this radio, at least most of them. There may still be a couple more in there. And so it's ready for alignment. But before I perform the alignment on it, I want to explore its operation very thoroughly. And then I can perform the alignment and become aware of what kind of improvements or what's going on. So I've had great success in the past with a few radios using my SDR, which you see in the lower right corner there, to reveal three important factors all at the same time, and that really helps with the alignment. The three factors are the local oscillator frequency, the tuning of the IF, which should be at 455, but maybe it's not, and the last thing is the front end resonance curve or boost, which boosts the selected frequency that you're trying to tune while rolling off all the rest. Now, with a few radios, I've had great luck at simply putting this coil right here somewhere in the radio where it can actually pick up enough to produce all three of these, let's call them signals, on the SDR display at the same time. Well, then I can start looking at the relationship of the three of them and learn an awful lot about the radio at that point. With most radios, my luck in doing this hasn't been nearly as good. I can almost always get the local oscillator onto the SDR, and that's helpful in itself. And quite often I can examine the what's going on in the IF circuits with this technique, and that's a little bit helpful. A little more exploration there might reveal more things that can be determined doing that kind of test. But the one that I have the most difficulty with is getting the front end of the radio, the front end response curve, to appear on the SDR. So that's probably what I'm going to start with today. Why don't we get this radio playing here? So I've set up all the equipment already and done some preliminary stuff just to make sure what I've done is working well enough that I can carry on and do some more experimenting. Right now the radio is hooked up to a large loop antenna, which is just behind me here in the shop. It's coming in on this cable here, just hooked up to the antenna inputs on the radio. Now that should give us a pretty strong, clear AM signal. I believe the antenna is tuned somewhere down in this range, around 600, 650. So let's go down there. So this is 590. Well, let me just tune the antenna a little bit. Oh, first I think I want to put this on full voltage here.
It's too complex. Yeah, certainly, but at the same time, the fact that a player is asking another player to be accountable, that's much better than me or Charlie asking. But interesting. Last year I had a chat with John Herdman, who is the Canadian men's national team soccer coach, and he was talking about dealing with millennials.
Okay, so to make sure this radio is tuned 100%, I have a voltmeter watching the AVC voltage. That's what this lead is doing here, this one here, which you can't quite see. So it's simply in contact with the wire that's going to the first grid cap on the first tube. The first tube is the mixer tube, and the voltage from here is showing up on this meter. Okay, so this is on the 15-volt scale, so it's about 5 volts. And as I tune the radio, you'll see the AVC voltage go up and down, down, tune it back in. So I can tell when the radio is perfectly tuned by peaking this meter, which I will do. Okay, so it's tuned in perfectly on 590. I'll tune the antenna now. I'm watching the same meter. There we are. So let's listen to this radio now. It's perfectly tuned.
Get misrepresented, so that we're trying to create clarity.
Like you've been here almost, I guess, it's about a month, right? Or a little, maybe just slightly over a month since players reported, since pitchers and catchers reported.
Well, yeah, my impression it sounds really, really good. Considering too, the speaker's just sitting out here; it's not in its cabinet. So I think a couple more explanations here of what's going on. I have the scope here. Let me reset my camera again. So the scope is listening to the diode output of this radio. So in other words, just past the diode, the detector tube, where the audio is now, I don't want to say recovered, but I'll use that word, has been recovered or made available is maybe a little better way of putting it. That audio is being picked off from the back apron of the radio where there's a link for a phono to be put in. So that's right where the radio audio output comes out on its way back into the audio circuit. So it's a great place to catch the audio fresh, let's put it that way, right out of the radio. And that's what you're seeing up here. Now, enough said about that. There's a reason why I've done this. You'll see in a minute why I've done it this way. So we can be quite convinced the radio is actually working quite well. It's tuned in. The dial is almost dead on. So I suspect someone has aligned this radio fairly recently. But maybe not. You could have this dial perfectly accurate, but have the local oscillator off, and in compensation have the tuning of the IF off the other way, so to speak. And the result is accurate dial. At least accurate at one spot. As you move it across the dial, it may no longer match the dial markings. It may no longer be, I don't want to say linear, it's not quite the right word for it. But. So let's switch now. We're going to introduce another piece of equipment, which is the sweep generator. Sorry, I'm thinking about too many things at once here. So this is a sweep generator. I have it set to sweep from 490, up here just a little bit, 490 kilohertz, so that's just below the start of the AM band, up to just beyond the top of it, 1690. And it's going to sweep as soon as I do this. So it's now sweeping a signal out of this cable. So I'm going to take the cable and put it where I'm going to remove the loop antenna and put, here, let me just do it. Let's just do it. Okay, so antenna gone, sweep, I do this here, sweep connected. Oop. No I don't, I need this. Sweep almost connected. So now you hear a buzzing sound. The buzzing sound coming from the radio is the sweep passing the tuning point where this is tuned. So each time the sweep reaches 590, it causes an output to come from the detector, and that output is what you're listening to. You're not really listening to radio audio. You're actually kind of listening to the carrier, sort of. I guess that's the best way to put it. You're kind of, I don't know how to explain exactly what you're hearing, but you can see it up on the scope here. So the scope is now set so that the low end is the bottom of the AM band, 530, 540, and the top is 1600 or 1690, whatever it was. And so as the output of the generator passes the tune point of the radio, a output comes from the diode output from the detector, and that's what's happening right here. You see it's driven negatively the way I have everything connected. It is a negative voltage. This is the voltage that's used to generate the AVC voltage. So let's just study that for a second now. You can see there's almost no AVC voltage, yet the radio is receiving something. The thing is, it's receiving a radio signal just momentarily as the sweep passes by. And during that moment, an output comes out of the detector, and for a moment it can charge up the AVC circuit and the AVC capacitor, but only for a moment. The regular radio station continues to push carrier and through the IF and produce a detected output that's going to charge that AVC capacitor and raise its voltage up. But this just isn't enough. So let's think about this for a minute. The radio is receiving a strong signal from here, a sweeping signal. The AVC cannot accommodate such a quick passage of the signal. So consequently, the radio's sensitivity remains very high. So we have basically a strong signal going into a radio that's got a lot of sensitivity. So it shouldn't take much to overdrive the output or to produce loud sounds out of the speaker with mysteriously weak signals going into it. Simply because when you normally feed a strong signal into a radio like this, it automatically turns itself down. So strong signals never sound strong because of automatic volume control. But in this case, because of the way it's being done, the automatic volume control just can't keep up and is somewhat defeated. So this is something to think about when we're looking at this level of voltage here. And what is this level of voltage? Let's see, it's a half a volt per division, so we're down 1/2, so it's about a volt here. Now see if I got egg on my face. 15 volt scale, so it's about a volt here. Okay, so everything I just said didn't seem to work out. Well, that's why I'm doing these experiments. I have stated my hypothesis. I should not feel bad if it turns out not to be true. So the hypothesis is the AVC voltage will never match the signal strength coming in on a sweep, effectively to control the front end input on the radio and prevent overloading. Didn't quite say that last part. Prevent overloading. In other words, prevent a powerful signal from driving the grid on one of these front end tubes into the nonlinear zone of that tube. Everybody got everything? So now I'll finally state what I'm really concerned about is driving the front end too hard produces a bunch of weird behavior in the radio under this scenario that I could then get caught up in trying to analyze because I haven't realized what it is I'm trying to realize right now, which is this AVC issue. Let's experiment a little further here because I'm talking too much. We don't even need this sitting in the radio right now. Put this on 5 volt scale. So on the 5 volt scale we're reading, well, who's coming? Someone's coming. We're reading just a hair under a volt. So first I'm going to tune the radio. This will move this point around and we'll watch the AVC and see if it does anything. Oh my gosh, Peanut. So I'm going to guess what's happened now. Yes, Peanut. I guess what's happened now is I've actually tuned the radio beyond the range of the sweep generator. So the sweeping signal is gone in the sense that it's not coming out of the IF anymore. The radio is behaving just like it would anyway. It's just receiving some noise here in my shop from whatever. And that's giving a nice AVC voltage over here. And if I tune it back into the range of the sweep, Okay, there. Oh, Peanut. What is it today? No, you go out, and I'll be up in a bit. So interestingly enough, you may have noticed already that the AM scale here is starting around 55, 54 actually is where it's starting. 5400 is ending 1900. Why? This last little bit says police and amateur. So this radio in the AM band is trying to reach up into the old police band, which was just above the AM radio band in the early days, followed by some amateur radio just above that. So consequently, the sweep is ending here. If I really wanted to sweep the whole way, I'm going to have to make it end way up here. Well, that's got to be 1800, 1900 or so. Okay, let's discover it. I'll change the settings on the sweep and make it sweep higher and higher on the band. We'll hear it when it reaches this frequency here. So I think we'll try this. 1689. It's not sweeping now. We'll set it up to 1800 first. Okay, let it sweep. Just noise, no buzz. So we're not there yet. Go up higher. Try 1900. You still don't hear it. Okay, let's go a little higher, just like this, when we hear it. There it is. 1945. So this tuning point is roughly 1945 kilohertz. I hadn't noticed that. Like a secret little additional band at the end of the AM band on here. Of course, you're not going to hear any police in here anymore. In fact, you're not going to hear much of anything in here except a bunch of noise. My understanding. Although between 1600 and 1700, there was an extension to the AM band, and there are stations in that area, usually very low power and interesting stations, if you can get them. So let's get the sweep going again. So it's just kind of on the edge here. I really don't get a good. So we'll go down to 1600, back in the regular radio band. A lot of strong noise in here. That's competing with the signal out of the signal generator. Okay, looking for a good spot. Yeah, that looks like a good spot where I'm pretty sure the only thing, you can see it on the scope here actually, the amount of noise is these little tiny bumps, which you may or may not be able to see on the video. But you can certainly hear that the noise is really suppressed. So we got a really good spot now. Okay, what can we figure out from this? Good question. Well, I think it's time to engage the SDR, which has been sitting on the bottom of the screen there, not really doing anything. So first, my hand around it and see a change. You see the delay in the SDR because it's a computer that has to work on the information before displaying it. So I'm going to put this right near this first tube here, which you can't quite see. This is the first tube. It's a detector tube. Just going to put it in between here. Nowhere particularly special, just don't want it to short on anything. Okay, now we're going to look at that display, but I'm going to put it full screen so we can get a good look at it. Now, somewhere on there should be the local oscillator frequency. We have the radio tuned up around 1500, so it should be about 1050, somewhere around there. So if we look on the SDR around 1050, I don't see anything there. Okay, we're going to tune the radio back and forth a little bit, and something should move right around 1050 back and forth. Oh my gosh, all kinds of stuff moving. Oh, you know what? I'm wrong. It's up there. It's up there at 1900. Oh yeah, what am I thinking? I was subtracting the... okay, let's recalculate. So at 1400... well, I'm getting a warning about space in my computer, so I think I'm going to get kiboshed here shortly. But let's finish this. 1400 should yield a 455, higher than that, 1855. Okay, so we're looking at the SDR. Here, and the local oscillator is right here, and the frequency is right there, 1856. It could be 55. Okay, so what that's telling me, I'm going to go back to the camera view here. Okay, so what this is telling me now is with the radio tuned to 1400, it's producing a local oscillator at, I've forgotten the frequency, at exactly the right frequency. So all indications are that this radio is tuned very, very well. It may not be tuned in terms of strength, but it's tuned accurately for the dial. Now, the next thing we want to try to see with the SDR, and this is a little tricky, is to look at what's going on inside the IF itself. So I'm going to move it a little further down the radio where it's going to be a little more IF signal, I would think. And then we're going to take the SDR, I'm going to full screen it here again. And we're going to try to expand on the 455 area. Okay, so the 455, whoops, there we are. 455 is right in here. So in here is the IF signal. So I don't really see much of anything there. So I'm going to turn up the signal level of the sweep. I'm going to turn down the volume here. I'm going to give it a lot more signal. That's me turning it up and down. Wow. Okay, I'm muffling the speaker so we don't hear it so much. Well, I don't think I'm getting anything on the IF there. Let's move it to this spot here. Let's see. Tune the radio back and forth a bit. And just looking just on the 455. So those things that are shooting back and forth, I don't know what to say about those. But just on the 455, you know what? This is not showing up. You're not getting it. You're not getting it here. How come, Jim? So I'm trying a few other spots with the coil. Let's try let's try it again with the antenna here. Maybe the sweep is just not going to produce the kind of thing in the IF that really stands out. So experimenting is the way to go. So I believe. I need to put the ground on the loop here. No loop without a ground. Okay. We're down this area.
And why back to the head.
Yeah, because they love them and they don't want to let them down. I appreciate the call, but you know, in this article, we're thinking it's a good read. It's by
okay, so I know it's receiving a strong signal. You can still see the audio even though you can't hear it. You can see it up here. Now, to the SDR. Oh, okay. I was on a bit of edge of the sneeze there for a bit. Okay. So looking again in the 455 area, right in here. Tuning the radio back and forth a bit. Yeah, we're really not getting anything here. Oh, coil's not in the radio. Okay, that was done. Coil in the radio now. Yeah, see, there's malarkey in there, making it difficult to spot the real 455 action. Okay, I'm a little stumped here. Let's try something totally radically different. My coil's not doing it. What we'll try here is to make a more direct connection. Right into the radio. Just 1 second here. This is the antenna input for the SDR. The SDR is just sitting on my bench there.
A big deal, this FBI case and the charges that these, 40 some odd people are facing. But I do think there's some hypocritical outrage going on. Yeah?
Yes, and but not William H. because he didn't know anything about it.
This will silence the radio.
He was not charged because he was
Pretty
not
sure.
aware of what his wife was doing behind
And
the
Omar Rush was against it the whole time, so he said, sorry, honey, I
Well, let's
can't
just
be a part of it. So now
Even with the radio is shut down beyond this point. Let's see what we see at this point. Oh my gosh, look at that. SDR is doing some interesting stuff now. Oh, okay. So when I'm hooked to the grid of the IF amplifier, what should be on this grid is mostly 455 stuff, and there may be some other artifacts there. We should see a strong signal in the 455 area here. So I still don't see a thing. So I'm going to tune the radio back and forth a little bit, and we should see some stuff roll around inside there. Nothing whatsoever. What in heaven's name am I doing that's so bad here?
Rogers Business Internet Pro with complete business grade.
Let's try that. Hey, there we go.
I am interested.
Excellent. Okay, so at 455 now, you can see something funny going on there. Perfect. This is exactly what I wanted to see. Look at the waterfall display. See how weird that looks too? Those are things passing through the IF. Past the IF frequency. And anything that hits 455 or right in that range will come out of the speaker. So what we're going to do now is we're going to expand that 455 area on the SDR. Bear with me while I mess it up, and then we'll bring it back. Okay, now we'll go to the 455 area. Let's get there this way. So 455 is right here now. Doesn't look very expanded, does it? I'll tune the radio and you can watch things roll around through there. Let me just move the red line off there. So the area we're looking at is right in here. Right in here. I'm just going to tune in one direction across the band. Okay, and you should see what looks like things are kind of rolling past that point. Not like anywhere else on the display. And you should also hear it. Let me turn up the radio a bit. Now, I've tuned way off the resonant point of the antenna, so the signals are low. So we got something interesting on the oscilloscope too to take a look at. Okay, so now we'll tune something in.
In New Zealand on Friday, it's a despicable story. It's heartbreaking. The shooter reportedly streamed the massacre on Facebook Live for 17 minutes, and police are urging people not to do it. It's extremely distressing footage that's been circulating online, and as soon as you come across something like this, report it immediately, because Facebook
okay. Let me hit the zoom. The zoom isn't up. That's why it doesn't look any different. Let me increase the zoom here. Not sure why it went back to the way it was. Oh, you know what's maybe something to do with the fact that I'm close to the zero here, I think. So let's try this again. Whether it's about Muslims or women or gay people or interesting. So 455 is. It's incredibly important. We all have a responsibility, I think, especially on this conversation. We're going to talk to a guy who is very familiar with alt-right. And again, it's not expanded. Son of a gun. I got to get this expanded. I just don't know what I'm doing with my SDR here. Okay. With that in mind, I want to play something that the there we are, 450. Yeah, let's leave it like this. It's good enough. So 455. I'll put my. Let's put this right on. So the red line will be right on 455. So that red line now on the SDR is marking the ideal center of the IF, but it may not be the actual center. But that's where it should be. Now we're going to tune the radio. So you can see clearly the IF is peaking here. Instead of 455, that looks like 460. Let's see what it actually is. 462. So maybe this radio's IF is 460. Now I'm going to tune this station you're listening to either edge of the IF, back and forth. So right now you can still see the carrier, but you can't hear the content of the carrier anymore. And if you look in the center of the IF curve there, if I can call it that, you see there's something there. You can hear it. That sounds like automobile ignition noise. I tune to the other side now. Now, what's happened here is, I believe, the reason you can't hear that noise anymore is because the AVC voltage has gone high. We'll take a look at this in a minute. So the noise is there, but it's just so quiet now in the face of this strong signal. You can't hear it. Okay, moving on, right to the edge here. Oop, wrong way, other way. So you can still see the carrier there quite clearly, and but you cannot really hear it. Maybe a little bit, but the noise has become central again. Okay, I'm going to do this again so you can see the AVC voltage. ABC voltage is here. The SDR you can still see on the screen, so you can still watch what's happening. So we'll put it right in the center. Wait a minute, I've got to give myself something to look at here. There. There's that mysterious ticking slowing down. This is a mystery noise in my own house here, what this ticking is. Sometimes it doesn't exist, other times it's here, and its rate varies a lot. It's not coming from this radio. That ticking is not coming from this radio. Okay, let's carry on. So we want to watch this. Watch it for its maximum reading here. There. And we look at the IF. It looks like that signal is dead center of the IF passband, even though the IF passband appears to be a little off. No mystery in that. That means as much juice from the IF circuits at the frequency that we're listening to. There's enough juice there to drive a fairly high ABC. Now, what next? Well, I'm just, you know, I also didn't say this at the start. I have a radio here that's working really good. So every test I do is the test of a radio working really good. The result should be telling me the radio is working really good. That's what I expect. So in a sense, the good working radio gives me an opportunity to test all my tests, which is kind of what I'm doing here.
Compared to the 3-year 60,000 kilometer offered by most competitors. Fact. The difference between 80,000 and 60,000 is 20,000.
So what I'm pondering here is what do I need to pay attention to now to know about improvements in the radio as I go through the alignment process. So one of them obviously is the ABC voltage from a known input signal. The better and better the radio works, the more and more juice from the signal, sort of from the signal, that comes out of the detector, the higher and higher we get here. So, and that's a typical thing about alignment. That's a typical way to do it. I better find out what the proper frequency is before I do this, because maybe it's 460. I'm assuming it's 455. Then the next step will be tune up the IF. Put it dead on whatever it's supposed to be. Yeah, I can't think of any more to do with the fooling around. What other fooling around can I do here? By the way, the way the SDR is getting its signal right now, which I did off camera, is that's the input. This scope lead is the input to the SDR up here, and I just have it. Okay, let's get back at that after quite a long break here. So yeah, that video section you just watched, the segment you just watched, ended suddenly because my hard drive got packed. So I've had to copy off a bunch of files here. We're ready to get going again. We're getting ready to do the IF alignment here. So I'm going to use this signal generator here. It's set to 455, but it should be 460 for this radio. 460. The output of the signal generator is showing up right here, going through this capacitor, basically onto the grid of the first tube in the radio. Very good. Shouldn't matter where the radio is tuned. It's quite interesting. It does matter. You can see the ABC voltage going up and down. That's interesting. Why is it about this spot right here? 650, 460, 930. So if this was reacting up here at 930, I wouldn't be surprised. There's no reaction at all. So don't know why it's doing that, but it is. Don't worry about it. We'll just go down here. Okay, so the name of the game is adjust these two IF transformers and make that meter happier than it is now. Let's see. Get a tool here. Let's try that. This one's pretty stiff. Okay, so I want to start on the second IF, not the first. We'll just pick the bottom. Okay, now I'm watching the meter there. Down. Okay, so this is dead on the money. I think this is what we're going to find out about this radio, that it's perfectly tuned. This one here, there we go. Down, you can barely see it, and dead on. Okay, now we'll try this one on the bottom. There's a resistor right in the way here. Okay, now we're watching the meter. Down. Down both ways. So yeah, I think we'd be pretty sure that somebody, otherwise it's just remained perfectly tuned since the day it was built. Next one here. Down. Up, 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 up. Ah, we got one that was off. Oh, we got something out of that. Let me go back down below. Okay, here we go. Up, up, down, up. There we are. Well, a little bit surprising. 3 of them really pretty good. 1 not so right. But now they're all correct. We're still on 460. So that corrects the IF. Now the thing about this radio was the pointer looked to be perfectly accurate across the dial. Having changed this ever so slightly, it may not be so perfect anymore. Why don't we check it? That'd be a good idea. Let's check it. So I'll take off this input here. Okay, and we'll put this onto the antenna. That's 455 shoved into the antenna. You can barely hear it. There is a trap in here, a circuit designed to catch 460 kilohertz either going out to the antenna or coming in from the antenna, either way. So we get to that alignment issue down the road, but obviously it's killing this pretty good right now, which is fine. So what we're going to do is we'll dial this up to exactly something. How about exactly 1400? So that's smack dab on 1400, and what we'll do now is we'll adjust this to 1400. Oh, it's almost dead on. So low signal strength. Let's see if it'll get it. Yep. Well, it doesn't get much more accurate than that. What I'll do is I'll set this to 1400. And we'll tune the radio and see where 1400 shows up on the dial. So it is off. Oh wow, barely off actually. When I get down here and eliminate the parallax, it's barely off. In fact, it's so little inaccurate that I would call it right on. Let's go to the other end now. We'll try 6. Dial this right on 6. That's the IF leaking through. 6. Okay, I'm looking at the AVC meter. That's top of the meter. 6. 6 right on the money. So, well, we haven't done any harm yet. That's excellent. Excellent. So the next step is to try to make sure that the front end tuning is matching the tracking of the local oscillator across the dial. And I think that's what I'm going to work on tomorrow. Because it is a little late in the afternoon now. It's 2 o'clock in the afternoon. I got a little bit of work getting this video ready and the like. And so tomorrow we will examine the IF, the shape of the IF response curve. We'll take a look at that. And then we'll try to look at the front end and see if its tuning matches the dial pointer, or we'll see what it is. My impression with this radio is it's right on the money, so I'm not expecting it to be way out. Its performance is still excellent. Great, so thanks so much for watching, and I'll see you on the next video.